Yeah, so last week we met only me and Yuri to, talk about the last chapter, which was basically just discussion about, chatting about future direction of what we have seen about the transformers and some of the limitations. And it turns out that we were only two. We say, oh, okay, let's just meet today, and we can basically chat, along some of the topic in the chapter, and talk about some of the recent stuff we have been seeing about diffusion, if anyone has something. So Yuri, do you have anything to talk about the diffusion?
I don't think I'm prepared to kind of discuss it. I posted a really good blog by Jay Alamar that does illustrated. He like, I think he's been doing like illustrated explanations of different deep learning methods. So he recently did stable diffusion. I don't think I can discuss it better than he like wrote it. But yeah, but I didn't get deeper into it than just kind of go through the blog.
Yeah. Okay. So what I can do, like maybe I can just share our final slide, this for the chapter, so that we can just chat together. Can you see my screen?
Yes, we can.
Okay. So is it what can you see? Is it my Jupyter notebook?
Yeah, we can see all the tabs.
Okay.
Right. And yeah, I think this is VS Code, right?
Oh, yes. Okay. So, this is our last session for this chapter. And it basically talking about the future directions, scaling, what somebody, like maybe if somebody is doing research, some areas to look into. So they start talking about, I think, the first thing they talk is about, scaling transformers, like how can we scale transformers? So we can see, like, I think the patterns here is like we started this, and, transformers, we are moving and moving. And what they talk about this, growth of these transformers is that we are just adding, making more larger language models, because we have seen like a performance is so good. We are just scaling up the version of original previous models. So that's what they discuss here. But they talk about, like, do this scaling up obey the power law relationship with the model size? Like, does it mean like when we have model that is bigger, it's more capable to do, funny things, something that is human-like stuff? So this is what they discuss here. And they talk about, scaling laws, that allow us to empirically say that the bigger is better. And, they finally talk about, we can see, like, we have compute, we have data set, we have parameters. So does that mean, we have more compute or more data set or parameters? Which one do we need to increase, to basically makes our model better? So I think what they said here is, you can see, like, many researchers, what they basically do is to, tweak some of the architecture, and hyperparameter. This is what people normally do, try to, make more parameters, increase the parameters. But what they suggest is, like, scaling this in tandem, like the data set, the parameters and everything like this, to, scale them up so that, it will be better. So that's what they talk about. Anyone want to add something here? about the scaling. All right. So they also discuss about sample efficiency, that, you know, large models are able to reach, the same performance with smaller models, you know, trained with, limited time. And this shows us the compute performance here. But, we have seen like these are some of the scaling. So in a nutshell, what they're saying here is like, scaling makes model better. But my understanding here, they also talk about some of the challenges with, scaling models. Theoretically, in practice, we can see, like they said, like when you scale the model, you have better, but there are many, issues they discussed, such as infrastructure, the cost of training large models, the data set creation, model evaluation, deployment. So for me, I have not trained like, anybody here with experience on this, how it affects your, model wise scaling. Anybody with experience about it, data set creation or evaluation or deployment? Yeah, so, I mean, the data set creation, you can see they talk about like, though language model require large or high quality data set, but it turns out that, in this real world, when you graph data, because, these data set they are graphed from internet, it turns out it may contain toxic content. So one needs to basically, make a very good effort to see that the data does not contain, this kind of toxic content. So this is really challenging. There is a recent work from Big Science, maybe Big Science, which is a year project from Hugging Face. Basically, they involve like more than 100 people to create the data set. They are creating, a free and open language models, which is called, anybody can remind me the language model from?
It's the Bloom, I suppose.
Bloom.
Yeah.
Yeah. So I contributed for the data set for Bloom, because like they involve my language, and the chatters here, they want us to make the data set like doesn't contain any toxic content in those languages. So for Bloom project, many hundred people are involved to make sure that the data is quality, and also the infrastructure. So you see, like training this kind of.
I'm sorry. How did you did you guys actually literally have to clean up your data? What was the process? What was the process like of getting your data prepped?
Yeah, so because I speak a particular language, we need to sit down and curate those toxic words in that language. Words that we know, like they are offensive, they are derogatory, some stuff like that. We need to create them manually and try to filter them out from the model. So
you did stuff. So did you do things like you basically use like keyword search to find pages or documents? Yeah. Okay.
Yep. Yeah. So this is one thing, like, this project is like 1 year, and they are releasing, I think, the Bloom language model next week. So right now, Bloom paper is being written, so it will be released, and you can see like the infrastructure, billions of dollars, and, so each team, this Bloom paper, language models, it involves 100 people, because like it's open source. So more than 200, 300 people. So each team, their infrastructure. So these are tons of people that are just dealing with infrastructure that have experience with that. Cost, it was given, by, French, something like that, government. So it's something, grant they get. And data set more than 100 people, model evaluation, more than 100 people, work on that, deployment, separate people. So what they are saying here, I think the challenge involves, it needs multi-level with different kind of expertise and, yeah. So they also discuss about, that these, language models, creating them, it involves, cost and stuff like that, and they are closed source like GPT-3 and stuff like that, but this community-led project, they are now creating, language models which are open, and one can basically, just like Ethereal and Big Science, yeah. So they also discuss about, some of the challenges with, attention mechanism in transformers, and where are some of the, future research directions. So they talk about, there is a key challenge associated with self-attention, which is basically, that weights are generated from pairwise comparison of all the token in sequence. This layer becomes computationally bottleneck when trying to, process long document, So I don't understand, really grasp this, but they say the recent research in transformer is making the self-attention more efficient. But this is the key challenge. Anybody with the idea what they are saying here?
It's with respect to the, yeah.
Go ahead.
Yeah, Darren, go ahead. Okay, I will go ahead on this one. This is with respect to the scaling of the architecture. The scale factor is the order of n square, where n is the length of the sequence. So as that's the big O notation. So yeah, that's what they are trying to specify here.
Okay.
Darren, you had something to add?
So yeah, more simply, it's pairwise comparison is the problem, right? And that's in the attention mechanism, I'm assuming. So each word you have to figure out how similar it is, or what the attention weight should be for that word to all the other words in the sequence. So that's what they mean by pairwise comparison. And pairwise comparison is a very inefficient thing if you've ever done any kind of pairwise comparison, right? So you have to do every single individual with everyone in the group, and then take the next individual and do that one with every single token. Yeah. So that's, I think that's the heart of what they're saying. Is that right?
Okay.
Yeah, true.
So, okay. So I think, this is a challenge, but they say the future research direction people are taking is how can they make this, kind of comparison more efficient. So these are some of the, work that they are just trying to do that, performer, transformer, and this, what they are doing is how can they make this, this, pairwise comparison to avoid that, to make this more efficient. They also discuss, I think, something called sparse attention. Which so they want to explore, research future direction. How can you, these comparisons make it more efficient? The sparse attention. So we want to create something like sparse attention here. They say one way to reduce the number of computations that are performed is self-attention layer is simply limit the number of query key pairs that is generated. So as Darren said, like this pair, so maybe to decrease this number. So if you decrease, it means you have, I think, sparse matrices, which, the computation may not be, expensive as the previous one. So I think that's maybe some of the stuff they discuss. They also discuss something linearized attention, which is also an alternative to make this operation more efficient. I don't understand this. Anybody can explain this one? This, linearized attention. Yeah, because this is a standard attention. So they talk about, they suggested something called linearized self-attention. So we can see here, like there isn't this softmark, but yeah. So, and I'm not sure how this differ from this. All right. So they finally goes into, talking about beyond text. They talk about, for example, we have seen Transformer can do a good job for classification, question answering, but they said there are some limitations. Some exam is, human bias. What this means is that, okay. Okay, they talk about human bias, common sense reasoning, modality, all these, human bias, talking about, the bias that we can see from, the model. So if model, for example, they talk also about facts. I think this one, I think I didn't copy it correctly. Okay, so we all know, common sense reasoning, because now there are, a lot of work about common sense reasoning. But I think what they are saying here is that, there is still challenge, to have a model to reason like humans, and also modality, the transformers we have just seen in all this in this chapter, they're about, text, but, a model cannot combine, image and text to make some kind of informed decision, but they talk about, recent progress involve, this stuff. So this brings us some of the works that have been now recently. So they discuss about, some transformers like such as IGPT, which, talk about that, and yeah, so that's I think what we have, going beyond text, they discuss about that, and also multimodal transformers. So multimodal transformers, I think they also discuss them, speech to text. I have not gone through these since last week. They also talk about other such as the clip, which we said we can, talk about them today. So anybody has, anything to talk about, these kind of recent work that's diffusion, which about this one. So yeah, so this is, I think, the last part of the chapter that it discuss about, using these, DALL-E clip, which are basically not, text, but the image. Yeah, and the research is now going, and now we are moving toward this kind of diffusion models, which are basically, proving to be more effective to that. And which I think the book, when the book was written, there were not these kind of diffusion models, but now, I think the challenges toward this, image is becoming less as a challenge, though it's, I think, challenge, but I think it's getting better. Yeah, and they said, yeah, so that's what I got to just as a summary for the chapter. So anybody can, come to the boat from what you read.
Yeah, this was an interesting chapter, giving us an overview about what Clip and DALL-E and those things were in 2021. So this is a year-old book. So yeah, the state of the art architectures in 2021 were described in this book, and the most common way.
So like Clip, it basically combined text and also vision, right? So Clip, this one, I think, the Clip, yeah, this one. So we can see, I think this is I'm not showing. So Clip, like, yeah, Clip with image and text encoder, and yeah, the old also the layered LM. I think Darren talked about layered the other day when I joined the Darren, you shared late, right? One, yeah, it was late.
What's it called?
Is it,
All
okay,
that?
Are you thinking layout LM, right?
yeah, layout,
Oh,
LM.
oh yeah, layout LM. Yeah. There's a lot of work in the document, like
Yeah,
business document understanding
yes,
sort of
yeah,
area. I mean, I know it's broader than that, but yeah, very interesting. So not only are things going in the direction of larger and multimodal, and not only multimodal means there's more data, so you keep going with the theory that you keep getting bigger and you have emergent, properties, and it gets better and better with size, but you also have specialization of models to particular types of tasks, and not like the traditional, and one of those is document extracting from semi-structured documents, which is very valuable to companies. There's a lot of interesting specialization stuff going on.
yeah. And the other one they talk about, which is BQA, that also, allow us, I think it's question answering stuff, but with image, given an image, with text, so you can ask question and give the answer. So they also discuss about, so I think the challenge is about multimodal transformers. And now I think multimodal transformers are getting much better. Yeah, if they will write the book this year, I think they will say they will, not talk much about the challenge, because now, more progress has been done. All right.
Yeah, right now.
So can someone give an intuition?
Yeah,
Sorry,
go
Mike,
ahead, Derek.
So I was just going to say, can someone give a rough intuition on diffusion model? I know we have the whole blog there, but I've looked at it before. I can't remember, but I do believe they use transformers, at least on the text side. Can anyone give a very rough connecting the dots between what we've learned and that diffusion?
Yeah, I think the kind of processing pipeline is the same as the other image generation models. I think the only difference they do is that when they do, and again, I might understand might be slightly wrong. So when they do, the whole idea of how do you do vision and text together is you jointly train embeddings, like image embeddings and text embeddings.
Okay.
And so the innovation they did is they described the image or coded the image in the latent space, and when they do generation, they do it in the latent space instead of the pixel space. And of course that's a lot more efficient. So then they, and because
so by
of that,
latent space, you just mean the dimensionality reduced space, right? Rather than the
yeah, but latent
so
space for that image, right? Like you can roughly speaking, like a latent space, when I think of latent space, is that if you have like a image of the person, you can give every pixel, or you can just say, oh well, like the head should be oval, and like you can parameter, like I'm always thinking of latent space as parameterization, and you can describe a person like a stick figure with, like, I don't know, maybe 10 parameters, and then but of course they do it automatically, so they pick like the best parameters somewhere in the neural network.
Yeah, the best way will be, I think so, if you open up an image besides what Yuri is trying to describe, it will be helpful in navigating the architecture as to why the diffusion models is taking the image in the latent space as opposed to the data in the pixel space. So yeah, it's a very helpful figures that Jay has used in his blog. Jay Alma. Yeah. So yeah, I think so. If you go through that, then it will give a very solid overview of what they are trying to visually describe.
Okay. Thank you for. Right. Okay. So thank you.
I have another quick question. So does anyone like so I understand it's very fascinating, right? Everyone like now generates images automatically.
Yeah.
With stable diffusion, but like what's sort of like, but I don't work in this space, so like the generation of images, like it's exciting but doesn't help me that much. But like what would be the next, can we use those more generative models in other ways, like you know, like what would we learn from it, like what would be the next steps to do that was my kind of, because it's interesting, but I can't really use it in my work, but
Yeah.
I'm wondering, like, is there like something that I can learn from it and use it somewhere else? Like what's a bit like, is it like you can now would that help like a language, like a normal language generation models? I don't know. What
Yeah,
would be like, you can do like a, like one thing I can think of, like I can like generate reports with figures. That would be like a, that sounds true, or maybe is true.
yeah, you can use diffusion LM, the diffusion language model. There's a very good research paper along with the code base for that too, in which they are trying to generate language and then music, then videos. The list is going on and on. This diffusion has taken the whole generation, the generative AI space by storm. And yeah, everybody is trying to.
What would be the what would be the input for those? So how's it different than GPT-3? Just because you can generate multimodal at the same time, or is it the input that's different with the language LM?
For that, I do not know the details of that, but yeah, they are trying to use the as noise in the tree, the classifier, the tree vectors. So it, if I read a sentence from this, and they are trying to iteratively denoise a sequence of Gaussian vectors into word vectors, yielding a intermediate latent variables of decreasing noise levels. So as in the image, they are trying to do the same thing, but with respect to the parse trees or the classifiers, which are Gaussian vectors, and which are a sequence of Gaussian vectors. So yeah, they do that and yield an intermediate latent variables, and they perform gradient updates on those latents to generate those those languages with which with the proper thresholding and the control requirements of the diffusions models that they require for. So yeah, that's the process, a high level process from what they are trying to do. But if I say it simply, yeah, it's much like the thing that we do in the image thing. Yeah. So yeah, it's the same process, but the vectors and the latent space are converted to text form to give us a better representation of the language model space.
Yeah, they seem to be saying you could have more fluid control of the output, language output generation.
Yep. Yeah, as you have shared in the chat, that Darren, yeah, it's the same.
Huh. Interesting. Was that what you were thinking about, Yuri? Something like that?
Yeah, that's I was wondering if I can just then combine it with also like a language with some numeric data.
Yeah. Yeah, that table to doc would be awesome. I think there's probably some stuff out there like that. Yeah. Like, is there any model that goes from image to text, but not OCR? There's got to be something for that, image to text.
Image to text.
Yeah, why not?
Yeah.
I'll look around.
Image to text LM.
One side thing like a usage I can think of. So I deal with very strictly defined data, basically like a data definitions. So usually when people have to like understand it, it has very, very precise meaning, and you take like it takes experts to distinguish between like a very like fine differences between them. So, but maybe if I can generate not just description but visualizations and like numerical data characterizing like those definitions, I think that would be an interesting addition. So like people can not just read the text, but look at the images or look at the numbers.
Yeah, interesting.
All right. So that's a good ride to the end of the book. And yeah, thank you all for joining the discussion. Yeah.
Are we calling the authors yet?
Yes, that's what I want to talk. So do you think it's good now? Can we just chat with the author, or we just leave them if we don't have, because like I think if we don't have anything to discuss with them. Yeah, I think this what's his name? He was like he had some question that he started to give, but I think he might be busy quite a bit now, Jakob. So yeah, do you think we should invite them, or you don't have any question? We just leave them and move forward. For me, I don't have much to ask them, but if you guys have questions, definitely I can send them the message in Slack now to invite them possibly next week or week after, anyone that they are available. Darren, do you think you have questions, or we should just leave them?
Although I've used models a bit, but I really need to dig in and do some things before I'd have some do more stuff before I'd have any useful questions. I think I know Mike had some questions, but
yeah, but I think it will be quite useful, Maya, to invite them when we have something reasonable to ask. But yeah. All right. So anybody with reasonable questions that you think is for me, I don't have enough to ask. But if anybody is fine, so we can send them message. What about Maya? Do you have?
Yeah, I had a couple of queries with respect to the codes and
Yeah, so
why.
we can definitely. Okay, so I will send the message. Yeah, I will let you know in the chat in the group when it will be available. So I will ask maybe if they can be available next week. And what about the time? What can we ask them like this time? Or they should. Okay, okay. So I will say this time if they're available next week or week after.
Yeah.
Okay, cool. Right. So thank you all. I will definitely post the update about inviting them. I will just chat them now. So if there's anything. By the way, Darren, I missed today, last on Friday, the meetings. How was it? Because last week I intend to join, but you guys didn't have the meeting.
Yeah, I think we have like we've been doing this over 2 years, and that was like the shortest meeting we've had in the whole time. It was only 15 minutes. He didn't miss much.
Okay.
We're just like, yeah, I've done nothing. Oh, I've done nothing. I've read nothing.
Okay. Yeah.
So that's not normal. Normally we have at least something to talk about. But so yeah, you're anybody's welcome on that anytime they want, especially you've been in there before. We look forward to seeing you in there again, and it can be random. That's fine. Whatever you feel
Yeah.
like.
Okay. Yeah. So, yeah.
Yeah.
That's yeah. Okay, cool. So thank you all. We see next week, when we have the authors.
Great. Thanks, Steve.
Okay. Thank you.
Thanks.
Bye. Thanks.
Thank you
Bye.
guys. Take care, everyone.
Thank you, Sam.
Thank you, Yuri.
Bye.